All right, first off, I'm gonna ask you what's your name and what made you get into IT?
Alright, I'm Zachary Tyler. I've originally first got into IT. Well, actually, it was kind of random. I have to back way up to get to the very beginning. And it was when I was a little kid. I feel like maybe every kid asks their parents this at one point, like, "Hey, mom, what do you want me to be when I grow up?" And she responded with computer programmer.
Really?
Yeah, and I didn't think anything of it. I didn't even really understand what a computer programmer was. I was a kid, and I didn't think about that at all for years. And then I graduated high school and was gonna go to college because that's what people do. And when I came time to pick my major, I had no idea what I wanted to do. So looking at the stuff, I was like, okay, I'll do something with computers because computers are cool. You're making money nowadays.
Yeah, true.
Yeah, so I figured I would take a look at that, even though I didn't really know much about them, and ended up going for computer science, which is kind of ambitious given that it's like the hardest of
IT
the whole
field.
IT field. Most people default to IT, or even some people go to information systems, which is even easier.
True.
So I went for computer science because it sounded cool, and all of a sudden I realized I really liked it. I I I did one semester of just core classes, and then I went straight into computer classes, and it just clicked. I didn't realize I had a talent for it,
Mm.
and before I knew it, like I was doing better in my computer classes than I was doing in my core classes. Like it was just I realized that's what I wanted to do in my life. So just kind of made a hobby out of it after that.
That's real.
Yeah.
So, like, what challenges did you meet in your journey of learning more about computer science?
Um, I mean, there was a million. Particularly whenever I left school, I wasn't able to keep up. I didn't have the classes feeding me information, so I had to take it upon myself. And taking it upon myself was harder than I expected because computer computer nerds are really elitist. Like they kind of like that they're smarter than everybody else when it comes to computers, so they're not so willing to like help people out. It was noob. Literally, got called a noob so many times just on like random forums and stuff. I
Put
just
on the board.
yeah, like asking questions on forums. Oh, I noob. Oh, you should have just done this, you know. And I realized it was gonna be very hard to get help from other people, and I was just gonna have to Google everything, and I did. And before I knew it, I was picking up like every time I had a question, I just go, hey Google, solve my problem, and then that was one more thing I knew, and it would help out next time I had that issue. And before I knew it, that whole Google research just kind of amassed into something big. Yeah, and before I even knew it was
Google
there.
became your teacher.
Yeah, exactly.
Sensei Google.
Professor Google. Yeah.
So, what are you trying to get out of computer science? Like, what do you want to make yourself into, or what do you want to do with it?
Well, I'm still trying to answer that question myself, to be honest. But I do kind of hold an interest in cybersecurity, but I think I know that one day I'm gonna move past that because I love science, always have. Then I really want to take it to like the theoretical level, working on with computers on like a logical scale, and
Mm.
not just with the computer. Kind of like almost do most of my work on paper, and just kind of create the theoretical foundations that I might be used in the future. And I also want to make like more scientific applications of computers, like you mentioned, particle colliders. I really have this ambition to make theoretical, or I guess simulated particle colliders and stuff like that, so
Okay.
that we could find a more affordable way of delving deeper into physics without having to spend millions and millions of dollars on maintenance and engineering just to make these colliders in the first place.
True,
Yeah.
true. But with two parts in that, with actually, I guess, simulating it, do you think it will hold the same qualities as actually a hard run? And if you want to go there, like, do you feel like you have the actual background knowledge to go into simulating actual physics type actions?
Let's see, no and no, but there's still like these are things I've considered. For instance, starting out, there is definitely going to be uh, a huge difference in doing it in a real collider and then simulating it.
Hmm.
And I feel like the best application would be for a system of checks and balances between the two. If it works in a simulation, it might work in a real collider, and if it's not making sense in a collider, it might make more sense inside a simulation.
Hmm.
Because there is the fact that an actual collider is dealing with it physically; it's actually happening. And but then at the same time, colliders are extremely hard to analyze. It's really hard to pick up on what's going on. And a simulation will be able to help us fill those gaps in knowledge by giving us pretty much a logged playback of every single instance that happens inside of it. And I feel like pairing the two together will push the whole theoretical movement just forward completely, just because it'll have, like I said, a way of checking and balancing. And as for my experience with physics, I do have a well-rounded understanding of physics, but not nearly as someone like you who would have like a physics degree by fairly soon.
So, last thing, with actually simulating it, would you think it would be best if you had a actual program that actually highlighted the actual particles that would be, like, say, since you ran it through a hard action first, but you had certain particles highlighted or checked, so once it just recorded their action, so it actually have like a litmus of all the things they do, so once it gets ran through a simulation, it'll actually run exactly what it would do in real life.
Yeah, that was one approach I thought of, and it's much easier said than done, of course, because the whole problem we have is keeping track, like the whole Heisenberg uncertainty thing. When you're focusing in on something, it makes it harder to really judge if your calculations are correct.
Exactly.
And I feel like what you just described, where we're having kind of a systematic overlay of what's happening inside a collider, would be actually the end result of making simulations first, and then pairing the two together. So it's like running the simulation on top of the actual, the hard run of it, and then seeing if they both end up in the same place, or if the same particles end up colliding in the simulation as they do in the hard run. And then you can kind of see where the deviations are in the simulation running on top of the hard run, and then either figure out how you can make the simulation follow the path that the hard run ran, or find out or maybe even learn something from the way the particles behave that you didn't know about them before.
Okay.
Yeah.
Alright, well, once again, thank you.
And thank you.
And this was interviewed by Zakir for Zachary Tyler.